Okay, this is our third video reviewing these older concepts from the circles chapter. I just want to look at 10, 11, 12, and 13. So give that a shot, please, and we'll take if you'll just stop the video for a second and work on those four, that would be great. If you want to work the first two, then come back and you can watch me work the first two if you have trouble, and then you can try the last two by yourself. But stop now and see how many of the 10, 11, 12, and 13 you can do and do correctly. Okay, we're back with number 10. And let's see what we need to do here for number 10. Number 10 tells us sketch a circle with two non-congruent chords. Alright, so we want to get a circle, and we want it to have two non-congruent chords. So, a circle, two non-congruent chords. So let's get a line. Okay. Here we go. There's one. Well, this does not want to cooperate, does it? And there's one. Now we can see there that they're non-congruent, okay? Now, sketch a circle with two non-congruent chords. Is the longer chord farther from the center or closer to the center than the shorter chord? So let's look at that. The further away a chord gets from the center of the circle, the shorter the chord becomes. Do you see that? Here we have, the diameter is my longest chord, but as I approach, or I should say get away from, the center of the circle, do you see how much shorter the chord is getting? So is the longer chord farther from the center or closer to the center? A longer chord is closer to the center of the circle. Okay, that was a good one to have to think about. All right, number 11. Sketch a circle Q. Now that already tells me Q is going to be the center of this circle. So let's sketch a circle Q. Radius 10. And a chord XY that is 8 centimeters long. How far is the chord from... Oh, okay. I read that wrong. It is not circle Q, it's circle O. My bad. Easily fixed. Circle O. Okay. So we're going to put a chord in here, an XY chord. And that's 8 centimeters long. How far is the chord from the center of the circle? Now that distance has to be a perpendicular distance. So this is what they're wanting us to find. That 8 is cut in half by that perpendicular distance. And since one radius of the circle is 10, all radii are 10. So now I'm really just focusing on this right triangle. And I'm going to use my Pythagorean theorem to find my x. Again, the 10 is on the side by itself, so it is the hypotenuse. It's across from the right angle. Okay, 100 minus 16 is about an 84. So x is the square root of 84. That's going to simplify. That's 4 times 21. So it's 2 root 21. Okay, so in simplest radical form, or in exact form, as we like to say, my length is 2 root 21. Okay, let's look at 10, or 12 rather. Sketch a circle Q. This time it is a circle Q. I was looking at 12, wasn't I? Circle Q. Okay, here we go. With a chord RS that is 16 units long. RS is 16 units long. And it's 2 centimeters from Q. Well, I am so off scale, but that's okay. It's still going to work out. Now remember, when it says that it's 2 centimeters from Q, that means it has to be a perpendicular distance. So it's okay for me to put that perpendicular in there. And also that 16 is now cut in half, isn't it? So it's really an 8 and an 8 now. What's the radius of Q? That's what we're looking for right there. Just a little old Pythag. And this time that R is my hypotenuse. So we're going to have the square root of 68. Let's see if we can simplify that. That's 2 times 34. So it's 4 times 17. So this is going to be 2 root 17 in simplest radical form or in exact form. Okay? All right, and the last one that I wanted us to look at, number 13, sketch a circle P. Okay, let me get my pretty circle up here. Sketch a circle P. Okay, means the center is at P. Okay, sketch a circle P with radius 5. Okay, and a chord AB that's 2 from P. So we'll have a chord AB that's 2 from P, so that means it's a right angle. Okay, find the length of AB. Again, that radius, I can swing it around here. Any radius is 5. I'm going to put it down here. That means that radius is 5. And that 5 is across from my right angle. So that 5, that radius is serving as the hypotenuse of my little right triangle. This little right triangle. So I'm going to have 5 squared equals 2 squared plus, we'll make that half x squared. When I say half, I meant half of AB. So 25 equals 4 plus x squared. X squared is 21. So x is the square root of 21, and that doesn't simplify. But the question asks for all of AB. So if this piece is the square root of 21, I need to double it. So AB is going to be 2 square roots of 21 in exact form.